Welcome to Gradeful, where we could be tutoring you in the SAT or ACT from any location in the world, one-on-one instruction with a super qualified tutor, starting as early as today. Just reach out and let us know. Here we're going through College Board's Test 8, Section 3. What we advise is that maybe you pause this video, try the problem on your own, and look to our solution for help if you're watching it after the fact. If you're watching it in real time, you can also use the copy of SAT Test 8, which you can get for free on College Board's website or in the description, which leads you to College Board's website. And like we said, try the problems on your own and look to our solution for the most effective way to solve each of these questions. So let's go ahead and get started here. Gotta have my colors just right, everybody. Okay, so here we're just solving for x, so we'll combine like terms. Right here we've got 1, 2, 3 x's plus 3 more, so we've got 6 x's. Here we've got -3 and -2, so -5. Combining these like terms, you've got 2 x's, so you've got 7 plus 2x. Now you can maybe take away 2x from both sides and add 5 to both sides, giving you 12 here and 4x here, divided by 4 on both sides. X equals 3. So the answer to number 1 is D. Going over to number 2 now. Now here it's like a linear y equals mx plus b format. So you'll notice that I often don't bother with the letters of these questions because this is our y-axis, this is our x-axis, and you know, they're changed to different letters really often because it adds a little confusion, but I'll often just deal with x and y. The y-intercept here, which is b, is 0. You can see it hits the y-axis at 0. Make sure that's the y-axis. Make sure the origin is 0, 0, because false x and y-axes are a thing on the SAT to look out for. And your slope is your rise over run as you go from left to right. So you can just, if you're given a graph visually that you can just see like that, then maybe the most effective way to kind of quickly get the slope is to just pick 2 points that are easy to deal with. So 0, 0, and maybe 1, 2, and ask yourself, how much did it rise? How much did it run? So it rose by 2 and it ran by 1. So 2 over 1, which is the same as 2. So we just found out that the slope is 2. So y equals 2x plus 0. Now in the letters of the problem, the y that they gave us is d, and the x that they gave us is m. So we can easily take that y equals 2x and turn it to d equals 2m. And the answer for number 2 is A. Now we're going to number 3. And 3 is asking us for P in terms of the other variables. So they're saying, which of the following gives us P in terms of the other variables? So for people who are just beginning with algebra, P is right here. We can't get P by itself until we get the group that P is in, which is this group by itself. So in order to get the green P by itself, you've got to get the pink group all by itself. So to do that, you can maybe take that piece right there, E equals 0, not 0, plus 4m plus P over 6. And we want this piece by itself. So we can say, okay, well, what's happening to that piece? It's being divided by 6. So the opposite is to multiply by 6. So that's going to cancel the 6 here and here. And you get 6e equals O plus 4m plus P. Now we need P by itself. Well, what's happening to P? It's being added with O and 4m. So the opposite of that is to subtract the O and the 4m. So now this cancels, and we have P, which I'm switching sides, is equal to 6e minus O minus 4M. And the answer to number 3 is going to be A. Going over to number 4. Question number 4, they're telling us that RT is equal to TU. And the question is, why are they telling us that? They're telling us that because this isosceles triangle here that also has side RU to it has 2 congruent sides, so it's an isosceles triangle. And if you have a triangle with 2 congruent sides, then the 2 angles that are across from those 2 sides are also congruent. So if you have an isosceles triangle, you're going to also have 2 base angles that are congruent. And so with the 114, we can kind of say this green triangle has 114 and 2 unknown angles, but we now know that these angles are the same as each other because of the isosceles triangle. So we can say 114 plus x equals 180. And go ahead and solve that. 114 plus 2x equals 180. Take away 114 from both sides. You get 66 divided by 2, 33. So we just found out that angle R and angle U are both 33-degree angles. And we can go into the next step of this problem. So 33 right there and 33 right there. So what can we do now that we have those 2 angles that we couldn't do before? The answer to that is we can see this pink triangle here. So it's the age-old test prep idea of a shape within a shape. So this triangle didn't mean much to us before when we only knew one of the angle measures. Now we know 2 of them. The angles of a triangle add up to 180. So we can say 33 plus 31 plus this unknown angle has to equal 180. So 33 plus 31 plus x equals 180. 64 plus x is 180. Take away 64 from both sides, and you have 116. So now that we have 116 there, this is a 116 angle, and now we're left with supplementary angles. So we've got at the intersection of V with R right here and U right here and maybe S somewhere up here. We now know that this is 116. So what does this angle have to be? That's a linear pair. When you have 2 angles that form a straight line, it's called a linear pair. And those 2 angles need to add up to 180. So this angle and this angle have to add to 180, which means that the angle on the left, angle SVR, has to be 64. And so the answer number 4 is C, 64. Going over to number 5 now. The width of the dance floor is rectangular. Okay, so let's draw a little rectangle. And the width is W. Let's call this the width, W. The length is 6 longer than the width. So mathematically, that's 6 plus W. How do we get the perimeter here? Well, if these are the length and the width, the perimeter is just the addition of all 4 sides. So we'll have W plus 6 plus W plus W plus 6 plus W. So we just took the 4 sides, 1, 2, 3, 4, added them up, combine our like terms. We have 1, 2, 3, 4 W's, and we have 6 and 6 here. 4W plus 12, and the answer number 5 is B. Coming over to number 6 now. 6 will be our system of inequalities. So for a system of inequalities, we're going to want to get our answers by graphing them and by pretending that they're equations temporarily. And we'll show you what we mean by that. So for the first one, we'll pretend that we have y equals 2x minus 1. And if that were the case, then that means we have a y-intercept of -1 and a slope of 2/1. So let's go ahead and show that. Y-intercept of -1 and a slope of 2/1, 2. So you're rising 2 going over 1. So now it's actually not y equals 2x minus 1, it's y is greater than 2x minus 1. So we're going to do a dashed line because greater than would be dashed and greater than or equal to would be solid. And because it's greater, we shade above. If it were less, we would shade below. So we'll go ahead and shade that. We're shading above. Doesn't have to be perfect. So that's what we're shading. Okay, the other one, we'll pretend that that is 2x equals 5. Divided by 2, you get x equals 5/2. By the way, it wasn't really x equals 5/2, it was x is greater than 5/2. But the line x equals 5/2, which is 5/2 is 2.5. This is saying that x is 2.5. Two ways to look at that. That means it hits the x-axis. It hits x at 2.5, which is an intelligent way of seeing it that a student of mine just made me aware of. And also, it means we're talking about the line that's the collection of all the points that have an x value of 2.5. So just imagine 2.50, 2.51, 2.52, 2.53. And as you collect all the points that we know of that have an x value of 2.5, you get a vertical line. And the same thing would happen if we had y equals some number and we do the collection of all points that have that y value, it would draw out a horizontal line. So this is our dashed line because it's greater than or equal to, it would be a solid line. But x is not equal to 5/2, x is not equal to 2.5, x is greater than 2.5. So greater than means shade on the bigger side of it. So the bigger side is the right-hand side, and so we'll just be shading on this side of it. And that may not be the best color for that because we want colors that mix nicely. So let's try this blue. And this is a message brought to us by Microsoft OneNote, which has been crashing on me lately. Okay, so we're shading on the right-hand side of the line of x equals 2.5. And look what happens. The place that was also shaded in yellow turns one color, and the place that hasn't been shaded yet is a different color. So you can see with this wonderful tool by Microsoft that there's this area that was shaded twice, and that's going to be our solution set. So when you have a system of inequalities, you can graph them. You can pretend that there are equations to graph them. Then you just shade on the line that you're on the side that you're being told to shade. And this right here is our solution set. So now what are the y coordinates of all the points that are in here? So in other words, what are all the y values that start right here and go upward into the solution set? In order to find that, we need the intersection. Now we know that this is the line x equals 2.5. So we know the x is 2.5. But we can plug that back into either equation to find out what was y when x was 2.5. So actually you can't plug it into the bottom equation because that only has x. But in this one, we could say, well, y is 2x minus 1. So that's 2 times 2.5 minus 1, 5 minus 1. So it's 4. So we know this point is 2.5 comma 4. And we know that all the y values in this darker green solution set start at 4 and go up. So y is greater than 4. Now, by the way, 4 is not included in the solution set because these were dashed lines. So dashed lines mean that if you're right on the line, you're not in the solution. You have to be just a tiny little bit off of the line to be in the solution. which is why it's y is greater than 4 and not y is greater than or equal to 4. So that's number 6. Now we have number 7. Number 7 is a nice classic trick because we'll tell you before we start that it'll seem like this is the answer, but on radical equations, you have to plug your answers back in to check them. So radical equations, the writers of this question are gambling that a lot of people are not going to remember to check their answers. So also for radical equations, the general line of thinking is isolate the radical. Isolating the radical, getting it by itself, allows you to easily square both sides. So we can take away 4 from both sides of this, and we'll have square root of 2x plus 6 equals x minus 1. So we did minus 4 to get there. Now you can square both sides. That reverses the radical on the left, and it gives you x minus 1 squared on the right. X minus 1 squared is really x minus 1 times x minus 1. Now you can FOIL this part. So first times first, outer times outer, inner times inner, last times last. -1 times -1 is +1. And now we're in a nice classic quadratic solving situation. Once you have x squared, you have to have the instinct to get one side equal to 0, where you can employ factoring, completing the square, quadratic formula, what have you. Take away 2x from both sides and take away 6 from both sides. X squared minus 4x minus 5 equals 0. So now we have it in a nice quadratic ABC format, ax squared plus bx plus c. And we're asking ourselves for this BC factoring because we have numbers in the B spot and in the C spot, but nothing in the A spot. We're asking what two numbers add to -4 and multiply to -5. And the answer to that is -5 and +1. The zero product rule says these two things here are multiplying to 0. So we can set each one equal to 0. And you can add 5 here and take away 1 here. And you get your two answers, which are 5 and -1. So like I said, C looks like an enticing choice, but we have to remember to check our answers for radical equations. So plugging in the 5 to check that answer, if we do x equals 5, you have square root of 2 times 5 plus 6 plus 4 equals 5 plus 3. So that gives us square root of 16 plus 4 equals 8. 4 plus 4 equals 8, and 4 plus 4 does equal 8. So if we try the x equals -1, square root of 2 minus 1 plus 6 plus 4 equals -1 plus 3. And so we get under the radical, that's -2 plus 6 is 4. So square root of 4 plus 4 equals 2, -1 plus 3. Square root of 4 is 2. 2 plus 4 equals 2. And that says to us that 6 equals 2, which is not true. So the -1 did not work. So 5 worked, -1 did not work. And the answer for number 7 is B. Going over to number 8 now. Okay, number 8 says, let's get f of x over g of x. So that's x cubed minus 9x over x squared minus 2x minus 3. So that's f of x over g of x. Now we can just do a lot of the same stuff we always do. In the numerator, there's a GCF, a greatest common factor. Both of these terms have a factor of x in them. So if I factor out an x, then I have to do x cubed divided by x and -9x divided by x. So it'll look like that. If you need extra help on the factoring, be sure to let us know. We'll do a lesson on that. Going over to the bottom, that's a BC factoring situation because we have coefficients in the B and C spot, but no coefficient in the A spot. So the BC factoring says we need two numbers that add to B and multiply to C. So they need to add to -2 and multiply to -3. The two numbers that do that are x minus 3 and x plus 1. So -3 and +1 add to -2 and multiply to -3. So this is really important, just the identification of a difference of squares. So far we have the GCF that we used before, the factoring out of a GCF that we had to do in order to be good at this problem. And we also have the difference of squares that we have to be able to identify. The difference of squares idea says that if you have two perfect squares with a minus sign in between, literally a difference of two squares, it'll always factor to the square root of each part with a plus and a minus. Now, if you FOIL out a plus b and a minus b, you'll get a squared minus b squared, and it'll prove to be true. But we do so many of these that we have to be able to kind of identify them just quickly like that. So the x squared minus 9 becomes x plus 3, x minus 3. Again, it's the square root of each piece with a plus and minus. And on the bottom, we had x minus 3 and x plus 1. So the x minus 3's cancel, leaving you with x plus 3 over x plus 1. So the answer to number 8 is going to be D. Now we're going to number 9. Number 9 is asking us about circles. And it's very imperative for you to know the equation of a circle. X minus h squared plus y minus k squared equals r squared. And the center of the circle is h comma k, and the radius is r. So looking at this, x minus h is x minus 6, so the h is positive 6. Those negative signs wreak a little havoc there, but it'll make more sense when we explain the y. If I were putting, well, okay, just to tell you, the y center is going to be -5, but I'll show you sort of in the opposite direction. Let's say I had this equation and I put in x minus whatever I have for h, so that's x minus 6, and then y minus whatever I have for y, which is -5. So we're putting in -5 as the y value of our vertex, equals whatever. And so the double negative will become a positive. So what we're talking about is when there are negative signs in a formula, it creates opposite situations. It creates a situation where if I see +5 there, I know it's -5. And if I see -5 there, I know it's +5. It's a little confusing. But anyway, because of that, the y value of the vertex is of the center of the circle is -5. So you got a circle with a center of 6, -5. And the thing on the other side of the equal sign, that's your r squared. So 16 is r squared, which means that square root of both sides, your radius is 4. So this is your center, and your radius is just the number 4. So if nothing else, if you're just starting on this, you want to know that formula. So let's go ahead and envision what this looks like now. Okay, so we've got our XY axis like that. And we've got a center of 6, -5. So 6, -5 will be around here. Now the radius is 4. So we're going to go up, down, left, and right by 4. So if I go up, that'll be affecting the y value. So it'll be adding 4 to the y value. So -5 plus 4 is -1. So this right here is 6, -1. Taking away 4 from the y value, 6, negative 9. Now we're going back to the center and we're adding to the x value. Adding 4 to 6 is 10. So here we'll have 6, 10. And taking away 4 from 6 is 2. So 6, 2. So we can graph this circle by imagining what are the 4 values when you go up, down, left, and right by 4. And that gives us this figure here. So now the question says, PQ is a diameter, P is, okay, this is uncovering a little mistake I made. So start this over. And we were adding and taking away. So you have, you're taking away 2 from the x, so that takes you to 2 on the x side, but the y value is the same. So 2, negative 5. And you're going back to 6 and adding 4 to the x value from 6. So it takes you to 10, but the height is negative 5. So a little typo there. But back to the question. The question says P has coordinates of 10, negative 5. Just cleaning that up a little. Okay, so and PQ is said to be a diameter. So the diameter goes through the center all the way across the circle, and the opposite end of the diameter is the Q, which we already knew was 2, negative 5. So what are the coordinates of 2? A, 2, negative 5. So now we're going over to number 10 here. A group of 202 people went on an overnight camping trip, taking 60 tents. Okay, so this is our classical, beautiful system of linear equations word problem. And you'll, as you are maybe noticing, you'll see these once or twice on every SAT, at least. So for the system of linear equations, we're dealing with 2 types of items. So here, there are tents that hold 2 and tents that hold 4. So on another question is puppies and kittens, Sprite and Coke, hot dogs and hamburgers, who knows? But you have 2 types of items, and you're pretty much always going to be given the total. But for this problem type, what you really need are the price and the quantity of each of the items. So I know I'm going to get the total number of tents, total number of people, but I need to know how many of this tent or how many of that tent, or the price of each. So now by price, we don't mean money. We mean the value that comes along with each. So some of the tents hold 2 people each and some hold 4 people each. You know, it's the same math as if we said hot dogs are $2 and hamburgers are $4. So we know that we have the price of each in that sense. And so we need X and Y to be the quantity of each. So X can be the number of 2-person tents, and Y is the number of 4-person tents. So if X and Y are the number of each kind of tent, then 60 is the whole number of tents. So that's X plus Y is 60. The number of each kind of tent all added together to give you the total number of tents. Also, we have our price times quantity statement, which is just almost the same thing we do every time. So we have some tents that have 2 people, and there are X of those. So that's your price and your quantity. There are some tents that have 4. So the number that comes along with each is 4, like the price. And the quantity of those is Y. So 2X plus 4Y is the total number of tents, which is 202. So now we've got it down to 2 equations. A little bit of a crash there, thank you. We have 2 equations and 2 variables. So that's our system of linear equations. Generally, when the x's, y's, and numbers line up, elimination is better. And when it's easier to get x or y by itself, substitution is better. Here, I would say both of those are true. But for me, it would be easiest to just multiply the top equation by something that's going to give us x's and y's that cancel each other. So just a quick little timeout here while we look for, what are we looking for? There's 2-person tense, which is x, which is what we're looking for. So if we're looking for x, it means we want to get rid of y. So let's factor that into account when we figure out what we want to multiply by. We want to get rid of y. So let's multiply by something that gets rid of y in one step. So if we multiply by -4, this is what will happen. -4x minus 4y equals -4 times 60. So this is our situation that we can now just add straight down and solve. 2x minus 4x is minus 2x. The y's cancel. 202 minus 240 is -38. And divide by -2 on both sides, x is 19. So we were looking for x, it's 19, and we're done. And that's a lot better than finding y and plugging it back in for x, because we're here not just to get the right answer, but to get it most effectively with the least effort and the least time involved. So you can have plenty of energy to get through the rest of your SAT and maybe even to go out and have some frozen yogurt afterwards and not stress out over this test. So let's go to number 11 now. Okay, what could be the equation of the graph above? Okay, a couple of little backstories here. Let's just say you had y equals x squared plus 7x plus 10, and the question said find the x-intercepts. Now, by the way, x-intercepts are synonymous with roots, zeros, solutions, and kind of factors, but we'll talk about that right now. So if you're finding the x-intercept, the x-intercept, we're supposed to know that means y equals 0. Comes up a ton on SAT practice test 9, by the way. To find the x-intercept, y is 0. To find the y-intercept, x is 0. So if we're finding the x-intercepts, we're making y 0. So now we have a quadratic equation equal to 0. And having it equal to 0 is our permission to factor. So we're looking for two numbers that add to 7 and multiply to 10, BC factoring. And the numbers that do that are 2 and 5. So x plus 2, x plus 5. The zero product rule says we have these two things that multiply together to give you 0. So we set each one equal to 0. So x plus 2 equals 0, x plus 5 equals 0. A little neater there. And so we'll take away 2 to simplify and take away 5. So the purpose of this explanation has little to do with the actual problem, is to say that if you have a factor of x plus 2, that corresponds to an x-intercept or root of x equals minus 2. If you have a factor of x plus 5, that corresponds to a root or x-intercept of x equals minus 5. So how do you get back and forth between factors and roots? To get downward, you're setting it equal to 0. If I wanted to go back in the other direction, I would add 2 to both sides. So once again, you're setting equal to 0 by adding 2. If we added 2 here and add 2 here, we get x plus 2 equals 0. So you could say that you get back and forth between factors, which is what it looks like at the top, and roots, which is what it looks like at the bottom, by setting it equal to 0. So what's the factor that goes along with this root right here? Because remember, a root is the same as an x-intercept. If we had x equals -3, and you add 3 to both sides, you'd have x plus 3 equals 0. So nice and easy here. If you had x equals 2, you take away 2 from both sides, you'd have x minus 2 equals 0. So we're setting it equal to 0 to get back and forth between factors and roots. Here, a little weirder because it's 0, you have x equals 0. And so let's say we take away 0 from both sides, x minus 0 is the factor. So when x equals 0 is the root, the factor is just x. So we know now that the factors have to be x plus 3, x, and x minus 2. So that's going to give us this answer and this answer. It's going to give us A and B. But we know that the signs are wrong on C and D. We need x minus 2 and x plus 3. So now, last thing about this question, when you have curves that cross and bounce off the x-axis, where they cross the x-axis like they do here and here, that'll tell us that these are single roots. So single roots, roots that show up to the first power as factors, they cross through the x-axis. And then this root right here, the x, where it bounces off, if it bounces off the axis, that's a double root. It's the second power. Double roots bounce off the x-axis. So based on the fact that the two pink x-intercepts are crossing through and the burgundy x-intercept is bouncing off, we know that the x has to be to the second power and the other two roots are to the first power, and that's choice B. So double roots bounce off the axis and single roots cross through the axis. That's number 11. Now going to number 12. Number 12 is what we refer to as corralling. Corralling is the idea that without necessarily finding my x, so to speak, I can kind of move everything around to get it arranged the way I want it. So in corralling, you want to ask yourself, what's the difference between what I have and what I want? So what's the difference between 2a over b and b over a? First of all, it needs to be flipped. And you can flip both sides of this kind of equation. So we can say b over 2a equals 2 over 1. We took both sides of this and we flipped them both upside down. And that is allowed. So now what's the difference between what we have, b over 2a, and what we want, which is b over a? There's that pesky number 2 on the bottom. So how do you get rid of a 2 on the bottom? You multiply by a 2 on the top. According to the rules of math, as long as I do the same thing to both sides, that's okay. So the 2 on the top cancels against the 2 on the bottom, and we have b over a equals, and on the right-hand side, we have 4 over 1, which is just 4. So the answer to number 12 is going to be D. Now we have number 13. Okay, 13 introduces us to some of those little subtleties that really kind of mess us up on the SAT. We're talking about our x value, which in this case is t. T is the number of years after 2000. So in other words, our two x values, which are our years, here they're calling it t, no big difference, but they're not 2000 and 2013. They're the number of years after 2000. So 2000 is 0 years after 2000, and 2013 is 13 years after 2000. So same thing is being done with the y value, or what they're calling f here. It's 4 million barrels and 1.9 million barrels. But the y value, the f, is being described in millions of barrels. So when it's 4 million in 2000, that means the y value is 4, because it's 4 in millions, and 1.9 million in 2013. Now, if you really want to become a student of the subtlety with which the SAT makes simple things much more complicated, first of all, we talked about how 4 million and 1.9 million are turned into 4 and 1.9, and 2000 and 2013 are turned into 0 and 13. But really, really subtle, something that I'm sure gets many students, is that these numbers were put right next to each other. So how many students who took this test, because this was an official SAT before it became a practice test, how many students said 0, 1.9? I know, because I think I've been duped into doing it myself a couple times. So now that we have everything sorted out and perfectly organized, we can go ahead and solve. Slope is your y2 minus y1 over x2 minus x1. We're getting the equation of the line because we see all the answer choices are y equals mx plus b's. So you label them x1, y1, x2, y2. If you want a way to do this with no confusion. So y2 minus y1 is 1.9 minus 4. x2 minus x1 is 13 minus 0. 1.9 minus 4 is negative 2.1. 13 minus 0, 13. So that's our slope. So which of these slopes match that? Well, there's no 2.1. They're all 21s at least, or 19s. So what they're doing is multiplying the top and bottom by 10. So negative 2.1 times 10 is negative 21. 13 times 10 is 130. And now we have a slope that matches one of the answer choices. And the answer to 13 is C. We don't need to find the rest of the equation because there's only one answer choice that has the right slope. So that's number 13. Number 14 is giving us a situation and asking us how many solutions. So there's a couple things going on here that are really pervasive trends on the SAT. First of all, we're talking about an intersection. Because if I give you two functions and I say, what are the solutions? I'm really saying, where do they intersect? So for an intersection, we say that you get both as or in the y equals format and set them equal. So we already have y equals x squared plus 3x minus 7, but for the other one, we have to work a little. We'll add 5x and take away 8. So y equals 5x minus 8. So you have y equals x squared plus 3x minus 7 and y equals 5x minus 8. The idea of the intersection is to just set those equal. X squared plus 3x minus 7 equals 5x minus 8. Because at the place where two functions intersect, they have the same x and y values. So you can set, what we just did is essentially we set the y's equal. Another thing that's going on though is that we're being asked how many solutions. We're not being asked what are the solutions. So if I say what are the solutions, I'm saying find the answer. If I say how many solutions, I'm saying what's the number of solutions. And the number of solutions for a quadratic equation, something that has y equals x squared, is code for the discriminant. I'm sure some people listening to this have already studied the discriminant in school, and some have not. So let's quickly just kind of talk about what the discriminant is. If you have the quadratic formula, and you do have to have the quadratic formula memorized on the SAT, so that's our quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. But let's just plug in fake numbers, just for the sake of this explanation, into the quadratic formula. I'll have 2 plus or minus root 4 over 3, 2 plus or minus root 0 over 3, and 2 plus or minus root negative 4 over 3. So what did we do? We created 3 possible values under the radical, the b squared minus 4ac part of it. So what's the discriminant? It's the b squared minus 4ac part of the quadratic formula. And it has a huge impact, as we're going to see here. Because in my leftmost example, when the discriminant was positive, we would be doing 2 plus root 4, which is 2. So 2 plus 2 over 3, 2 minus 2 over 3, and we're going to get 4 over 3 or 0 as our two answers. So we have two answers. If the discriminant equals 0, well, square root of 0 is 0. And if I add or take away 0, nothing happens. So the answer is just 2 over 3. There's only one answer. And right here, if the discriminant is negative, code for negative is less than 0, you can't have a negative under a radical. So how many solutions are there here? There are no solutions, the proverbial no solution, no answers. So if a question is giving you a quadratic situation and asking you for the number of solutions, they're asking you to just get this to a point where we can figure out what's b squared minus 4ac. So here's our problem right here. And instead of actually solving it, which would be a little more work, we're just going to arrange it as a quadratic. So in other words, quadratics always have to be solved by setting it equal to 0. So we're going to take away 5x and add 8 to both sides. So taking away 5x and adding 8 to both sides gives you negative 2x and plus 1. So this is actually a quadratic that would be really easy to kind of factor and solve. But just as a matter of principle, we can get our answer by finding out what b squared minus 4ac is. And this is an ABC. A equals 1, B is negative 2, and C is 1 for the ABC of that quadratic. So b squared minus 4ac is negative 2 squared, 4, minus 4 times the 1 in front of the x squared, times the 1 in the C spot. So this comes out to 4 minus 4 times 1 times 1, 4 minus 4, which is 0. And if the discriminant equals 0, we already said there would be one answer. So the answer to number 14 is C. There's one solution. But look how confusing this is. The discriminant was 0. So wouldn't it be really easy to pick 0 here? Even if you have a firm handle on this concept, just to have 1 second of kind of not paying attention, and you can get caught out there. So just be really careful and view the SAT, as we're doing, as a series of references to things rather than an intelligence test or anything of that sort. Going over to number 15 now. Let's go ahead and delete some stuff to make our screen look more clean here. So the question is asking us for h of o. So h is a function, and that's our f of x notation. F of x is basically y, but it allows you to say, if I have a number in there, what's y at some value? So for instance, f of 6 would be y. What's the y value when what's the y value when x is 6? Or f of 10, what's the y value when x is 10? Or f of a plus b, what's the y value when I replace x with a plus b on a harder question? So when they say h of o here, they're saying take the h function and plug in x equals 0. So let's do that. That's h of o equals 1 minus g of o, whatever that is. So now this is kind of a function within a function. This blue part right here is saying, go to the g function and plug in x equals 0. So let's do that. G of o is 2 times 0 minus 1. 0 minus 1, so it's negative 1. So now that we know what g of o is, that's negative 1, but be careful because it was 1 minus that negative 1 that we just found. So the answer will be 1 plus 1 because a double negative equals a positive. So the answer will be 2. But we know that most of the wrong answers on this question will always be 0, because if you're not careful with that negative sign, you'll get 1 minus 1 in a rush. You'll get 0. And choice B on number 15 would have been wrong. The answer is D. Now we're going to 16. All right, we'll be there someday, Microsoft. Okay, A is a solution of the equation and it's positive. So what are the solutions for this? The solutions are the x-intercepts, the roots, the zeros. They're what you get by factoring. To get the x-intercept, y equals 0. So this is kind of like saying y equals x squared plus x minus 12. And it says find the x-intercept. The x-intercept is where y is 0. So then we would have put 0 here. But they're already giving it to us in that format. But having it equal to 0 is your permission to factor. So okay. So you have the a, b, and c of a quadratic. We're talking about the numbers in front of the x's. So in front of the x squared is the invisible number 1. In front of the x is also the invisible number 1. There's nothing there. But 1 is an important number for all those single people out there. And c is negative 12. So negative 12 is the c of the quadratic. It's in front of the s, actually in front of x to the 0 if you want to be complicated about it. But the a, b, and c are 1, 1, and negative 12. And because we have nothing in the A spot, we have nothing right here, just the invisible number 1. This is our BC factoring, where we say, give me two numbers that add to B and multiply to C. Two numbers that add to 1 and multiply to negative 12. What two numbers do that? Negative 4 and 3. So this will factor the x minus 4, x plus 3. And our zero product rule says you set them both equal to 0. Add 4 here to solve and take away 3 here to solve. And your answers are 4 and negative 3. And now it seems to matter that they told us look for the positive answer, because otherwise we'd be confused whether to put in 4 or negative 3 here. So the answer to number 16 is not 4, because when I factored, I just made a little mental mistake myself here. And the two numbers that add to 1 and multiply to negative 12 are positive 4 and negative 3. So x plus 4, x minus 3. Once again, apologies. Set each one equal to 0. Solve each one, take away 4, add 3. And you get negative 4 and 3 as your answer. And the one that's positive is the 3. So the answer number 16 is actually 3. Going over to number 17 now. Here we're talking about the sum of the orange expression and the pink expression. So what's the sum of them? It's just the idea of combining like terms. Negative 2x squared plus 3x squared is 1x squared. X plus 7x is 8x. And 31 minus 8 is 23. So you've got x squared plus 8x plus 23. And it's in the format of ax squared, which is the invisible 1. So your a is 1, plus bx, which is 8x, plus c, which is 23. So what's a plus b plus c? 1 plus 8 plus 23, which is, for number 17, 32. Coming over to 18. Nice system of equations. The x's line up, system of linear equations, the y's line up, the numbers line up, the equal signs line up. Everything is just absolutely perfect here. And we have opposites right there. We have x and minus x. So this is just a nice softball toss of a question. You can add straight down. The x's cancel. Y plus 3y is 4y. Negative 3.5 plus 9.5 is 6. 4y equals 6. Divide by 4 on both sides. You get 6 over 4, which is the same as 3 over 2, which is 1.5. So on this question, you could bubble in 3/2, or you could bubble in 1.5, and they'd both be correct. So going to number 19 now. An amazing question in terms of how much more complicated this looks than what it really is. It's a linear y equals mx plus b. And the unit they're talking about is each quarter year. So x is the number of quarter years. It's just inherently confusing. But they're doing 2 new employees every quarter year. So if your slope is your change in y over change in x, the y-axis is the number of employees, and the x-axis is the number of quarter years. And in these slope expressions, the denominator is usually 1. So they're saying that we're adding 2 new employees every 1 quarter year. So for a y equals mx plus b, we're starting with 8 employees. The y-intercept is where you start. And the slope is 2, like we said. So y equals 2x plus 8. What's the value of the b of it all? It's simply 8. And the answer here is 8. And we are done with number 19. Going over to number 20 now. A is the center, BC is 2/5 of the circumference of the circle. So by telling us that this arc is 2/5 of the circumference, they're telling us that this pizza slice is 2/5 of the area. And they're telling us that this angle right here is 2/5 of the total degrees of a circle. So in other words, it's 2/5 of 360. So for fractions of circles, once you know the fraction, which is 2/5 in this situation, it's consistent. So the arc is 2/5 of the circumference of a circle, 2 pi r. The area is 2/5 of the area of a circle, pi r squared. And the central angle is 2/5 of the whole degrees in a circle, which is 360. But the idea is that the 2/5 doesn't change. Still the same fraction of the circle. So what's the value of x? X is the central angle. So it's the 2/5 of 360, which by the way is the same as 2/5 times 360 over 1. And a shortcut way of doing this would be to divide these two by 5. And so 5 divided by 5 is 1, 360 divided by 5 is 72. And now you have 2 times 72, and the answer to the question is 144. So thanks for joining us for section 3 of SAT Practice Test 8. We can start tutoring you in the SAT or ACT online one-on-one with a qualified tutor as early as today, so feel free to reach out.